All right, I turned on some debugs. The debugs I turned on was a simple debug called debug IPv6 neighbor discovery. And as you can see, it's going crazy because the neighbor discovery process is responsible for these router advertisements, these router solicitation messages. We can see here ICMP is responsible for neighbor discovery. So we have ICMP v6 that's responsible for neighbor discovery, and router advertisements are part of that. So we'll shut this off now. Oops. Let's do that here. Okay. So I'm going to scroll back up here, and you can see that there has been some requests to send router advertisements. So that is the process that's happening here. We've received some router solicitation messages at some point in time. We're responding with router advertisements. But what I want you to see here is that let's look for the A double colon. There it is. There's an example of us sending that router advertisement. Hey, this is my prefix. My prefix is 2001:db8:1:a /64. And we're sending that out our gigabit Ethernet 0/0 interface. So now, what does the PC look like? The PC on the other end, if we now analyze the output of ipconfig/all, we'll scroll back up here to our PC1 adapter. Our PC1 adapter says that we have these IPv6 addresses configured. So we have this IPv6 address, which is the one we are using, that is based on the global address of 2001:db8:1:a. And then we randomly generated, we didn't use the UI64 here, we randomly generated the ladder 64 bits. And I know we didn't use the UI64 because this is the MAC address. And that does not even look close to what the MAC address is. We also have a temporary IPv6 address that was created as well in this case. Our link local address stays the same. But what I want you to see here is that default gateway. Look at this. We automatically threw in the default gateway. Now, how did we figure this out? Well, when we received the router advertisement, it would have been sourced from the link local address of gig00 on R1. So this is the link local address of gig00 on R1. So it ends in 7340. Let's go take a look at that. Oops. Let that cook for a second. Typed in a command, the wrong time, and now it's trying to do a name translation right now. So we'll let that just time out for us. And then we'll go ahead and we will type in show IPv6 interface brief. While that's happening, let's double check what that address was. Ends in 7340. Seven, 340. There it is. So that's stateless address auto configuration, relying on those router advertisements. I want to take a look at show IPv6 interface gigabit Ethernet 0/0 right now. And you'll see down here at the bottom, it says hosts out this interface use stateless auto configuration for their addresses. Now, remember DAD is part of the neighbor discovery process. Well, DAD was used by our clients. So PC1, before it decided that it was officially going to use this particular IPv6 address, it sent out a DAD message, a duplicate address detection message. Essentially, all it did was send out a probe to this address. So it sent out a packet to this address. If anybody responds, it's already being used. If nobody responds, then it uses it itself. So this is the address that is unique in this local area network that we see right up here. Stateless address auto configuration on by default. So now what if you don't have stateless address auto configuration working? What happens then? Well, let's say we shut off router advertisements on R1. Let's say we don't want to use it at all. So I shut off router advertisements on R1's interface of gig00. Then how does our client decide that it wants to go get the DHCP server? Well, if there is no response to router solicitation messages from a router, meaning we're not getting back router advertisements, then the client goes and searches for a DHCP v6 server. It'll go out and hunt for a DHCP v6 server by sending the DHCP solicit message. And the DHCP solicit message is very much like your discover message for DHCP v4, but the solicit message for v6 is using multicast address instead of your broadcast address from IPv4. And then if you don't find a DHCP-v6 server, well, then you're not getting an IPv6 address, right? You're going to have to potentially statically configure your clients if you want them to have addresses at that point in time. So speaking of that, how do we statically configure our clients? Go to your PC adapter, go under their properties, go under TCP/IP for IPv6, click on properties, and there you go. Just like we had for IPv4, obtain an IPv6 address automatically using DHCP-v6 or Slack, stateless address auto configuration now. So both. Slack's checked first. If there's nothing from a router, then it goes and hunts for DHCP-v6. And then if we want to statically configure the addresses, we can do so by filling out the fields here of IPv6 address, prefix length, and then the default gateway.